Hello everyone, welcome to Civil Masters. Today we will see the standards of loading for bridge design, which is our lecture number 7. Now before we start, all lectures of bridge engineering will be uploaded here for the MPSC mains, which covers syllabus of MPSC mains as well as the previous year question papers. And so at last, please subscribe our channel, so that you will get the daily notification when we will upload the lectures. So you don't need to go each time and search the civil masters. You will directly get the notification. Now we will see the our lecture number 7, that is the standards of loading for bridge design. In sixth lecture we have seen the dead load, various types of loading, that is dead load, live load, impact load. What is the impact effect on the live load? Then we have see the lateral load. What are the provisions that have given by the IS code? Now today we will see the some other provisions related to the other loads that have given by the IS code. Now the sixth provision, that is the longitudinal force. For the longitudinal force, the forces due to braking effects should be assumed to act along the line which is parallel to the roadway and 1.2 meter above it. Very important, very important MCQ. They will ask the directly the value. So the forces due to braking effect should be assumed. So it act which is parallel to the roadway and which act 1.2 above it. So that is the, you can say that is the line of action of the force that have been acted due to the braking effects. Now in case of the 4 or more lane due to braking effects, very important, in case of the 4 or more lane, the forces should be reduced by the 20%. Now why it is reduced by the 20%, it is not our concern. Our concern is the, in case of the 4 or more lane, we reduce the forces by the 20%. Only these 2 points we have to remember in the longitudinal forces. That's it. Now we will see the centrifugal force. Now in centrifugal force, we know that the formula, that is the C equal to WV square divided by 127 R. We know the designation of the formula, that is the W means weight, V means velocity and R means radius. So by that formula we can calculate the how much is the centrifugal forces that is acting on the roadway. So this is the basic formula. You don't have to need to do analytical problems regarding this formula. You just have to remember this formula, because in exams like MPSC they will directly ask you the formula. They won't generally ask the analytical question that will be appearing in the GATE or the UPSC engineering services. You just have to remember the C equal to WV square divided by 127 R. That is the main our concern. And now, which is very important, the now what is the line of action of the centrifugal force, which is very important. So the line of action of centrifugal force is, the centrifugal force should be considered to act at a height of 1.2 meter. Remember, very important, 1.2 meter above the level of the carriageway. See, it acts along the level of the carriageway. It acts along the level of the carriageway, which is 1.2 meter above. So the centrifugal force which acts along the height of the 1.2 meter above the level of the carriageway. That question have been asked in the MPSC 2017. So important value, you just have to remember this value. Because in MPSC or in any competitive exam, you have to remember the standard values or the provisions that have given by the IS code. Now in engineering, what we do, we generally have the IS code, and by looking at IS code, we take the design, we design the whatever structure we have to design. But in exams like these competitive exams, they won't provide you the IS code or anything. They will only provide you the OMR sheet, and you have to answer the questions. So you have to remember the IS code provision, which have given by the our India standards. Now next is the seismic forces. Now what is seismic forces in earthquake design? We know that the seismic forces acts as per IS 1893. Now what is 1893? 1893 is the Indian standard IS code for the earthquake resistant design. Remember, those who have not know it, that they write in their notebook, that is the this is the IS code, or this is the IS code for the earthquake resistance earthquake resistant design, means in short form we call it as the ERD. We call it as the ERD. Now as per IS 1893, India has divided into five earthquake zone. India has divided into five earthquake zone, which is ranges from the zone 1 to zone 5. Now if we consider our Maharashtra, which lies in the zone 3, that thing you have to remember in the seismic force in case of the bridge design. We don't have to go into the theoretical concept. What is the seismic force now? What are the its effect? We don't have to go. We just have to stick to our basics, which is very important. Now next is the forces due to water current. Now if we see the forces due to water current, in case of this substructure design, the additional forces occur in which that is the due to water current. So the formula for the water current is the P equal to, which is the force P equal to 52 kV square. Now if we see, the K is nothing but the constant and V is as usual, we know that it is the velocity. So P equal to 52 kV square. Only that formula you have to remember. You don't have to go to the analytical approach. Only remember the formulas. Now next is the buoyancy. Now buoyancy in high level bridge. Buoyancy effect is due to the submerged part of the substructure and the foundation. Now if we see the buoyancy effect, now we know that the Archimedes have given the principle for the buoyancy. But in case of the when we design the high level bridge, we consider the only those parts have submerged. Means those parts who are who are under the water, only that part of the substructure and the foundation effect we consider by the design of the high level bridges. This question appeared in the MPSC 2018, so remember it is very important. Maybe they will ask you repeat the question. Now if you see the in MPSC exam, they ask the repeated question, so it is very important that we have to practice our previous year questions at least 2 to 3 times, and we have to look around. So now in exam they have asked the high level bridge, so we have to look around, means we have to see for the what is for the submersible bridge, what is for the design of submerged masonry or concrete structure, that we need to understand. Now if we see, next is the submersible bridges. Now in submersible bridges, full buoyancy effect considered. This full is very important. Full buoyancy effect considered on the superstructure, pier and abutment. If we see in high level bridge, only the submerged parts, only the part which are under the water, only that effect we consider. But in case of the submersible bridges, we consider the fully buoyancy effect on the superstructure, piers and the abutments. That is the difference. Now in design of next is the in design of submerged masonry or concrete structures. The buoyancy effect through pore pressure limited to the 15% of the full buoyancy. Now this value is most important. When we design the submerged masonry or the concrete structure, the buoyancy effect which is occurred due to the pore water pressure, we limit this, or we can say it is the maximum to the 15% of the total buoyancy. value is very important. 15% of the full buoyancy. That is very important. These three parameters we need to understand in the buoyancy. Now we will see the next, that is the temperature stresses. Now it is the most important. Why I am saying most important? Because in recent years they have not asked a single question on the temperature stresses, and it is the most important topic. There may have chances that in next exam they will ask the question on temperature stresses. There is a high probability on the asking on this topic. Now if we see the temperature stresses, there are some IRC recommendation. IRC have some provision for the different type of structure. That we will see according to the climate. Now if we see, now if we are designing, let's suppose steel structure, and in we are designing in the moderate climate. Okay, which is very important. Moderate climate, we are designing steel structure. The temperature which is lie between the minus 18 degree to 50 degree centigrade. Here I have forgot to write the centigrade. So minus 18 degree to 50 degree centigrade, that will be the temperature for the moderate climate in case of the steel structure. Okay, now we will see the next structure, that is the concrete structure. Now in case of the concrete structure, there are different provision for the different climate. So the for the concrete structure, in case of the moderate climate, temperature rise which varies from the 17 degree centigrade, and temperature fall also 17 degree centigrade. Now what is the use of this value? We don't have to get into that details. We don't have to design the bridge. We just have to remember the values, which will be important for our exam, or we can say competitive exam, in any exam which you are appearing. And next is the extreme climate. In case of the extreme climate, the temperature rise is 25 degree and fall is also 25 degree. Now these values are very important. As per my experience, the MPSC have the habit of asking the various number of question on this standards of loading and loading of bridge design. So in next exam they will ask the question on the temperature stresses. Now next, we know that the alpha value, we call it as the coefficient of expansion that we have seen in the strength of material. Now IS code have given the alpha value, that is the coefficient of expansion value, for the different type of bridges. Now we will see the what are these values for the different type of bridges. Now if we consider the steel and the RCC structure. For steel and RCC structure, the alpha value is, or we can say coefficient of expansion value is 0.000177 per degree centigrade. Per degree centigrade. Now, unit of alpha is very important. So its unit is per degree centigrade. Now remember the value, and let's see here how many number of zero there are. After point there are 40 and then 177, which is very important. They will ask the, or they will give the options, that is they will give 30 or they will 20. So there may be slight confusion between the value. So remember there are four zeros, and after the 177, four zeros. Now next is the plain concrete structure. Now in case of plain concrete structure, the value of alpha is 0.00000108. Here also the 40 and then 108. Remember by these tricks, and only then and only then you will remember the formula. This is the values for the, or we can say IRC recommendation for the temperature stresses. Now this is the most important topic. So you mark it or you write it on, that is the which is the most important topic. Now we will see the next, that is the deformation stresses and secondary stresses. Now these are the additional stresses which are acting on the while designing the bridge, so that we have to consider it. Temperature stress is also an additional stress. That's why we consider it. So in case of deformation stresses, now only for steel structure deformation stresses we consider, which is very important. Only for steel bridges, steel structure, we consider the deformation stresses. Now let's suppose in absence of calculation, we don't have the enough data. Then how will we calculate the deformation stresses? For that purpose, IS code given has provision that the we assume to be not less than 16%, not less than 16% of dead load and live load stresses. So this is the most important, or we can say there is a one MCQ that can be framed on the deformation stresses. Now next is the secondary stresses. Now in secondary stresses, increase in the permissible stresses may be permitted to 25%. Due to secondary stresses, what additional stresses? These are the additional stresses. Due to what? Those are actual stresses, they get increased, or we can say permissible stress get increased by the 25%. We permit it up to the 25%. Value is important. In design of RCC member, shrinkage coefficient is 2 into 10 to the power minus 4. We have seen this value in the RCC. Those who have not studied, for them tell you that the in case of the RCC or pre-stress, in pre-stress concrete, what we in pre-tensioned member, we take the value shrinkage coefficient 3 into 10 to the power minus 4. And in case of the post-tension value, we take the value 2 into 10 to the power minus 4. Now this value we have to remember. In case of this RCC member, in case of bridge design, we take the shrinkage coefficient 2 into 10 to the power minus 4. Now we have seen the all types of load that have considered in the design of the bridges. I have given the only the notes. You have to only stick to that. You have to study, or you don't have to remember all the theory part that have given in the your reference books. You have to just stick to the, because we are giving the only MCQ exam, we don't have to give the subjective exam. So only stick to the MCQ and the important value, that's it. Other than that, I don't think so that the any question will came, any question will came without these concepts or without this value. Okay, now we will see the next, that is the in case of the railway bridges. Now what is the loading for the railway bridges? Now we have seen the for the highway bridges, or we can say roadway. Now we will see the loading. What is the loading for the railway bridges? So our next point, that is the railway bridges. Now what is value for the railway bridges? Now we know that there are three types of track which are used in India. We mostly in our Indian railway use the three types of track. First is the broad gauge. We call it as BG, broad gauge, meter gauge, MG, and narrow gauge. Narrow gauge means NG. Now its value is 1676 mm, 1000 mm, and 762 mm. Now these values are important. You have to remember when we study the railway. Then you will get this value there also. So you have to just remember the what is the value for the broad gauge, meter gauge, and the narrow gauge. 1676, 1000 mm, and the 762 mm, which are respectively values for the broad gauge, meter gauge, and narrow gauge. Now strength of bridges. Now strength of bridges is termed as the MBG. Now what is MBG? Modified broad gauge loading. Now we calculate, or we strength of bridges we determine by the MBG, which is called as the modified broad gauge loading. Now, this question appeared in the MPSC 2017, and this is the new type of question. Any book have not covered this type of question, so MPSC may ask this type of question, so that you have to apply your knowledge and you have to eliminate the options. That is the only option will be available for you. So by this study you can be able to eliminate the options. So what is MBG? Now in next lecture we will see the different types of the recommendation which is given by the IS code for the cycle track or footpath. In next lecture we will see, and later we will start with the our low cost bridges. What are low cost bridges? What is culvert, or what is different types of culvert, that we will see in the next lecture. Now in standards of loading and design, this is our second lecture. In next lecture we will complete our the standards of loading for the bridge design. This chapter is very important. Minimum two question definitely asked in the MPSC exam. Now we will see in the next lecture, that is our lecture number 8. Till then, thank you, stay safe, keep social distancing.